So our topic is semantic annotation of documents. This project was done under the information retrieval course at IIIT Hyderabad. So the problem statement is, given the title and abstract of a research paper, we have to find the ACM classification category it falls into. The ACM classification tree is as follows. There were many categories, and under each category there were subcategories. For example, there were categories called general and reference, hardware, computer system organization. Under hardware there were subcategories called printed circuit boards, communication hardware, etc. So our goal is to tell that which categories the research paper lies into. Suppose printed circuit boards. We use 3 data sets. The first data set is presented by the C Lab of IIIT Hyderabad. It contains the following fields: the title, author, country of authors, year of publication, conference, categories, and abstract. The relevant fields to us were title and abstract, but the problem with this dataset was only for a very few samples the abstract was given. The second dataset is called the wiki dataset, which was manufactured by us. Corresponding to each ASIM category, we retrieved the Wikipedia page, and for that we took only the first section of it, as it contains the most important things, as in the abstract of the research paper. The third dataset is DBLP dataset, which was used for the initial phases of the project and later discarded. So we use 3 approaches for the project. One is the cosine similarity, the very basic model. Second is latent directly allocation. Third one is which we propose as the final model, and it is called the label LDA plus doc2vec. Approach 1, cosine similarity. For each ACM category, we retrieve the wiki pages as already explained in the wiki data. Then we calculate the cosine similarity for each TF IDF vector and each of the categories to test the research paper. So we have the research paper, we find the wiki page which is closest to it, and the associate category we give to the research paper. The second is latent directly allocation. What we do is generate data containing wiki description of each categories as an ASIM classification, run LDA to cluster documents. So we had 1500 categories, and we downsized this to 20 because then 20 clusters were formed. After that, assigning the category to the rest document whose description lies in the same cluster as wiki description of category. The problem with this approach is that in one cluster there could be many wiki pages and hence many categories. So the accuracy is not good for this. Only 15% we could achieve. The third is the proposed model, which is called the label LDA plus doc2vec.
LDA plus doc2vec. The main intuition behind using this model was that accuracy can only be improved not only by taking the words which are most common find in the abstract of a particular category, but also taking care of the semantic distance between the research paper and the categories. First of all, I'll explain what is labeled LDA. Now, labeled LDA is basically a probabilistic graphical model that describes the process for generating a label document collection. What it is basically is, in LDA, it is a better version of LDA, basically a supervised version of LDA, in which we assign labels to each of the document. Like in this case, the abstract of the research paper, we beforehand told the LDA that what are the topics which are made this document. So in this, instead of assuming that all the documents are made of the given number of topics, let's say 20, instead we already told LDA what are the topics which this document is made of, and so this gave us better results as compared to LDA. So using this, we got top 20 words for each of the categories. We took only 5 categories for our research for this project, which was AI, computer vision, database and information retrieval and other. So these 5 categories, we got the top 20 words which are present in the abstract of the research papers. Now using doc2vec, we made these top 20 words as a document which describes the category, and also the abstract of the research papers were each considered as document, and we mapped these documents to a 300 dimension semantic space. Now using the cosine similarity, we found the distance between each of the abstract which was mapped to the 300 dimension semantic space and the top 20 words for each of the category, and the one which had the highest cosine similarity, we assign that category to that abstract or the research paper or the research paper. So this was our basic model, which you can see in the screen. First of all, we generated data containing only the title and abstract of the research paper, for which we ran the labeled LDA, and we got the top 20 words for each of the 5 categories I mentioned before. And for the same we did for the testing data. We got the title and abstract of the research paper. Then we merged all these as a document and basically mapped this to a 300 dimension semantic space, and then we calculated the cosine similarity between the categories and the abstract, and the one having the highest, we gave that category to the research paper. And now we used mean average precision for measuring the performance of our algorithm, and we got a map score of 0.59 or 59.31%. Now main, as you can see in the results overview, it is much better as compared to the previous approaches that were used by us, cosine similarity and LDA. The main problem with that data set was that we had only 549 research papers with abstract, for which we used the label LDA to get the top 20 words, because of which our accuracy became 59.31. Had we got a better training set which had more abstracts of the research paper, we would have got a better set of top 20 words to give a better result for the test set. But since we had a less number of research papers for our training, we got this result. So that was a major achievement for this project, that even though we had such a data set, we got a map score of 59.31%. Thank you.